So as we read through this, a little bit different. So we were dealing with angles of elevation and angles of depression yesterday. We're certainly going to see some more of those here. I'll probably give you more of those in these little triangles, but these make you think a little bit too, and it's a good little review of all the SOHCAHTOA ideas that we've been talking about. So as that starts, it says an isosceles triangle. So if you remember, an isosceles triangle means you have two of the three sides that are congruent. So when I draw this in, as we kind of sketch this, I'm going to draw it in so that as best I can, not good artistic ability, these two sides here are the congruent sides. And then the third side would be down here. That then means this is 12.4 because I gave you two sides that are congruent. So those sides that we've marked congruent with little tick marks, those would have to be the 12.4s. And then this side down here would have been your 17. Right. The question is then asking, find the measure of the vertex angle. So when we're talking isosceles triangle, we talked about this briefly. Remember how we talked, if these two sides are congruent, then the angles opposite of them are congruent as well. So those would have to be the same. Now, we don't know if they are, and we don't necessarily need to know what those are right now. But what we also want to know is what those two sides are that are opposite of the congruent sides. These are what we call base angles. So if these two are our base angles, the congruent sides are the base angles, that third angle up here, this guy here is your vertex angle. All right, so that's what we're looking for. Now, to be able to do any of these things, Pythagorean theorem, sines, cosines, tangent, you have to have a 90-degree triangle. This is not a 90-degree triangle. So the way we're going to create that so then we can actually use some of those tools, let's just erase that, is to drop down, if you remember, an altitude. Remember what that was? That was when we go from a vertex and then drop it down here. What that really then is a perpendicular bisector in an isosceles triangle. So if it is a perpendicular bisector, that means these are 90-degree angles, which is good. It also means it takes this 17 and cuts it in half so that this length is 8.5 and this length is 8.5, so that altogether that base is still 17. All right. So now from there, we should be able to, let's say I ask you to find just this little angle right here. So if I ask you to find that little angle right here, and we now know that this length is 8.5, and this side here is 12.4, see what we remember from the last few days, set up your equation. So now we are ready, we have right triangles, so we are ready to assign either a sine, cosine, or a tangent equation to this blue angle up here. So look at our blue triangle, only worried about this one. The angle we're looking for is this, so I'll call this x. And then set up an equation for that. All right, then this is also, if when you have this set up, the type of equation that a lot of us have been missing on those little Canvas things that I've been giving you to see if we actually can plug these in. This is the type of equation we had a problem with. So then solve that and see if we actually can get this answer. All right, so Ella, you are working frantically back there. What did you choose, sine, cosine, or tangent?
Sine.
Good. So we want to pick the sine because sine is the opposite side. So here is this angle. The opposite of that angle is the 8.5. And then this 12.4 is opposite of our right angle. So that is the opposite and the hypotenuse. So that is why we picked that sine. So we would have this sine of x would equal the opposite side of 8.5 divided by the hypotenuse of 12.4. All right. And then from there now, we got to solve for x. So we need to get this x by itself. So we need to get rid of this sign. We have to get rid of the little sin, the sine function. The way we get rid of the sine function is with the second sign. So like I've been saying, you don't necessarily have to show it on the left-hand side, but that's what we're doing. We're taking the inverse sine of the sine. And let me actually kind of show you this too, this thought. Let's say I did this. Let's say I did the inverse sine of the regular sine, and let's say I put a 2 in here. All right, and then watch this magic happen. All right, that's getting rid of that inverse sine of 2, and then this should end up kind of being that answer. That's what we're doing, inverse sine of that sine. So these should then be canceling. And we have to do the same thing on this side. So the answer to this, plug this into your calculator if you haven't already. If you did, see if we get the exact same thing. The inverse sine of 8.5 divided by 12.4. So we do second sine of 8.5 divided by the 12.4. Oops. Oh, and then hold on. Everything in calc is in radians. Yeah, so let me put that back in. All right, do we get 43.27? Good. So 43.27 is that angle that we found. That's not the final answer though, correct? Hopefully. So 43, what did I say, 27? Is that right?
Yeah.
Okay. So understand what the question was asking. It was asking for this vertex angle right here. Didn't we just find half of that? Good. So we have the other half over here. That should also be 43.27. So we would want to double that. So if both of them, let's just do times 2. Both of those are 43.27. That is what, 86.54 degrees. So that's that angle. All right. All right. So that was a little new. Did we do 8 in this class? Okay. Try to set that one up. This is now our little picture. This is what we spent pretty much the whole day on yesterday, these angles of elevation and depression. See if we could draw this picture. It says an angle of depression, so kind of remember what that means. That's our angle that we look down at. So the angle you're looking down at from a 130-foot lighthouse to a boat in the ocean is 6 degrees. And then what we're ultimately then going to look for in the second sentence, the distance from the bottom of that lighthouse to the boat. And again, with all of these right now, some right triangle should get formed, right? In order for us to use sine, cosine, tangent, Pythagorean theorem stuff, the picture should eventually lead you to a nice right triangle. So see if we can graph that first, because that's really the only new thing that we weren't doing the previous couple of days. You were always just given the triangle, given the sides. Now we just need to create it ourselves with the words. Okay, hopefully we got the picture. Hopefully we're starting to form our equation. So let's sketch this out, see if y'all have the same graph. So you have the 130-foot lighthouse, and then it's on the ocean. You have this boat out here, and then you're told that the angle of depression from the top of this lighthouse down to this boat right here is going to be 6 degrees. So that's hopefully your right triangle. What you just want to be careful of is when we identify this angle of depression, when we talked about this yesterday, it's always like if you're standing up here, so if this is a person looking at the boat, if they're looking straight out, the angle of depression is always from what you would normally just look straight out to the angle you're looking down at. So this angle right here is the one that you would assign that 6 degrees. So we just want to make sure we're not calling it the angle that's inside of the triangle is 6. Because what we actually then want to understand is if this is the horizontal at the top of the lighthouse, if we go to the bottom of the lighthouse, that horizontal, this is now our transversal. So this angle here is its alternate interior angle. That would also be a 6-degree angle. Now we have our triangle. We have 2 of the 3 pieces of information we want. The third piece of information we want is how far is the boat from the base. So the value that we're trying to find is this right here, the bottom of that triangle. That's our x. Okay, now we set up, graph that hopefully. Okay, then from there, if I'm going to ask you what we're going to be setting up, if this is our angle that we're referencing, a reference angle, then we look at these 2 sides and identify, are those the opposites, the adjacents, or the hypotenuses, and then you set up your equation based upon that. So isn't 130 the opposite side of 6? And isn't 6 your adjacent side to 6? This would have been our right angle right here. Notice how we don't have the hypotenuse? We don't know that. So we don't want to factor in any that have the hypotenuse. So the only one that deals with opposites and adjacents is the tangent. Right? In this case, unlike that previous one, we now know the angle, right? So we can not have to worry about the tangent of the angle, or the variable. It's the tangent of 6 degrees, and then that would equal the opposite side of 130 over the adjacent side that we're trying to find. All right, and then that's the equation that we work our way through and solve. All right, so multiply by x. We don't want that x in the denominator, so we're now left with x times the tangent of 6 equals 130. Since x is getting multiplied by the tangent of 6, if I want to get the x by itself, I need to divide the tangent of 6 over. Now that's gone. Now the x is all by itself. Anybody got that? What do we get for this? 1,236.87? 246. 1,246.87. I get it eventually. 1236 point what? All right, and then that would be. We do want to put feet on here because there's a big difference between it being 1,200 feet versus 1,200 meters versus 1,200 inches, 1,200 miles. So the distance, we definitely want to assign a value to that. All right. Okay, hopefully we're able to do that. All right, number 9, a little different here. So this one we'll sketch together. So it says 2 buildings are 35 feet apart. The angle of elevation from the top of the smaller building to the top of the taller building is 42 degrees. So right away we got 2 buildings. One of them is smaller, one of them is taller. So sketch in a smaller building. So there's my smaller building. And here will be our bigger building. And then we know the distance between them. So from here to here is 35 feet. Let's read the second sentence again now. First time we've had to deal with one like this. So this is saying the angle of elevation from the top of the smaller building, so from right here, to the top of the taller building right here. So from the top of this one to the top of this one, we have an angle formed from here to here. So if I'm looking from the smaller to the top. Remember, the angle of elevation and depression is always considered on your horizontal. So if this is you're downtown, we're standing on top of one of the big buildings in the city, and you're looking to this one. Well, if you're not looking up and you're looking straight out, this is your horizontal. This is you looking straight out. So the angle of elevation is still this right here, from you looking straight out to you looking up to wherever you're looking up. So it is that angle that we're going to assign the degree measure of 42 degrees. Then the question is, find the height of the taller building. So what we're ultimately looking for is that full height of the taller building. Good. So smaller building is 32 feet high, Ahmed pointed out, so that's nice. So notice how I said this whole thing. The reason I drew in that little bracket or brace is because don't we know that from here to here, wouldn't that also have to be 32 feet? So what we really need to know to answer this question is this length right here that I have in yellow. And isn't that then, if we just talk about this right triangle that's kind of elevated, it shifted upwards a little bit, that's what we're looking for. So I'm going to call this right here the x that we are trying to find. If that's 10, then couldn't we say this is 42 overall? The 10 and the 32 would make 42. If x ends up being 50, then I would add these together. This would be 82. So we need to find this, add 32 to it, and then that gives us the size of that whole thing. All right? Still have to think a little bit, because if I'm going to use this angle and this side, don't we need either the hypotenuse or the base? All right, which one of those do we actually know? Say that again. So right now, like let's say I had a 5 right here, then I know the opposite and the hypotenuse. So I could do a sine because opposite hypotenuse. Let's say I had a 5 right here, then I have the opposite and the adjacent. I could do a tangent. Are either one of these two sides, so this side or this side, do we either one of those, do we have currently marked with a value? No, so that's a problem because we don't have enough information right now. But can't we mark one of those? Don't we know what one of those has to be? What's it going to be? Yeah, so even though we don't have it marked right here, wouldn't it have to be the same length as this right here? So we can assign a 35 to that length. And then now it's just another problem that we've been dealing with here. Just focus on this triangle here. All right, so shade all that in. And it's really just the same exact problem we've been dealing with. This is the opposite side and the adjacent side. So that's a tangent. So the tangent of that 42 degree angle is the opposite of x over the adjacent of 35. Right. That's, of all the equations, that's probably the easiest one. It's probably the one we're most familiar with. It's the easiest to plug into your calculator. You'll multiply that 35 over, and then whatever 35 times the tangent of 42 is should be your answer. Okay, Jenna, you got that? 31.5. And then I lied. That's not our answer, right? It's close to our answer. We need that for our answer because what that is, that's x right here. So I'm now going to go ahead and write this as 31.51. You said? I copied that one right. So that's the yellow portion of the tall building. The bottom blue portion of the tall building was 32. So if we now go ahead and add these together, which is ultimately what we want to have, the height of the taller building, you would say that it's 63.51 feet tall. All right. A lot of thinking, Ahmed. That's good, right? That's good. Nothing wrong with that. All right, let's do another. Okay, so we just got 2 left. All right, go to 11. Try to set up 11. Similar triangle problem that we did earlier. They're putting solar panels on the roof. Yeah, and it's right above our class. It was like my 5th period class. They dropped something. It had to have been unintentional because it sounded like the roof was going to come down on us.
Really?
Yeah. It was so loud. Everybody like jumped out of their seat. Putting some definitions up here too, just so we remember some isosceles triangle lingo. All right, so it's an isosceles triangle again. So just like you would have done in that first problem today, we kind of set that up as an isosceles triangle. We had two congruent sides. Both of those are the 27.8. What we also talked about, and it's been a while, when we deal with isosceles triangles, the two congruent sides are what we call our legs. So those are considered the legs. And then that third side that's not congruent to the other two, that is your base. So this is our base when we reference this word. So when it says the angle opposite of the base is 64 degrees, it's just a little different way of giving you the same information that we did in the first problem, that this angle right here is a 64-degree angle. All right, so that's what that means. And then the question is, find the length of the base. So first, do not be tempted, if we're looking for this length, do not be tempted by the Pythagorean theorem, right? Because we can only do the Pythagorean theorem if you have a right triangle. And we don't have anywhere in here indicating that we have a 90-degree angle anywhere. So even though we have two of the three sides, Pythagorean theorem is not an option. But you need to create a right triangle. So similar to what we did in that first one, we're going to drop down, and this ultimately becomes a perpendicular bisector. It's going to be perpendicular to this side, and it's going to cut this side in half. It also would then be an angle bisector. So instead of 64 for both of those, wouldn't these each then have to be a 32-degree angle, since we took the 64 and cut it right in half? All right. We all had set up so far. All right, then what we're going to be able to find, you won't be able to find the entire base, but if I just took this triangle, so let's do the triangle on the left, can't I find, if I put my X right here, can I find the length of the base of the yellow triangle? Whatever that is, similar to the previous one, it was the angle, you just double it to get the length of the entire base. All right, so if we kind of have that, if you have the yellow triangle here, all these measurements, go ahead and set up your equation. All right, Gavin, it's very comfortable. So what'd you set up, Gavin? If this was our angle, these two sides, we're dealing with what?
Sine 32 equals x over 27.
Good, perfect. So he's used the sine, because if this is our angle, x is the opposite side. 27.8 is opposite of the right angle, so that's our hypotenuse, so opposite over hypotenuse. And then this is the one that I think we're probably best with. Pretty simple on our calculator to plug in. All right, what'd you get there, Gavin?
For the answer.
Yeah. Well, yeah, for X. Sorry, for X.
14.73, and then I multiplied it by 2.
Good. So what he said, if you didn't hear him at home, he got 14.73. So that's this right here. And then he then said he had to then multiply that by 2 because this one over here would also then have to be 14.73. So if we multiply that by 2, what was that? 29 point what?
29.46.
46?
Yeah.
Yeah, that makes sense. All right. And then that's our limit. All right. All right. With that, I think that's probably the last one we're going to do. We're not going to get all hot and bothered about number 12. But the next page is your homework. Although I don't have it up. There was a lot of those, wasn't? Let me see how many I wanted you to do. I don't think I wanted you to do all those. Get that up.
Is it going to be due by tonight or?
No, it'll be due Monday. I like leaving the morning if there's any questions or anything. Let's see here. How many did I want you to do? These? Let's do. Do the evens. Let me get some of those triangles. So we're going to do 1 through 16, and then you're going to do the evens. Okay, so it's the next 2 pages right after that. That way we'll get some of those triangle problems. We'll still get all these angle of elevation and depression problems, but then that'll be our homework for Monday. All right. Okay, with that, that's all we got. We are through April. We have 1 month to go. All right, so if you are home, you guys can check on out. If you have any questions, let me know, and we will see you guys on Monday.
Everyone was kind of good with.
Thanks, Ale. You too.
Have a good weekend.
Thank you too, Nick.
You said 1 through 16?
Evens. Yeah, 1 through 16.